Hi, this is Zayed Alsayed, and I'm going to present my work on correction prediction for 2D SLAM. The aim of this work is to reduce the errors that are induced by the approximations in SLAM models. Our method is based on the Ensemble Multilayer Perceptron, which is a supervised machine learning model. The predicted correction can be applied a posteriori to the estimated pose. Two types of relevant information are used as input, making our approach independent of the sensor used. These inputs are the previous relative pose estimations and the likelihood scores distribution. Building and validating the approach involves three phases. The training phase, which is done offline on a part of the Kitty dataset. The testing phase that aims to find the parameters of the model that are likely to generalize the approach. And finally, the validation phase where we use the architecture selected during the testing phase. The sensor used in training and testing is different to those used for the validation. On this slide, we show the heading errors and suggested corrections. In red, we can see the real errors of SLAM that are calculated in comparison with the ground truth. In blue, we have the predicted corrections using our approach. Although the sign of real errors and predicted corrections is nearly always the same, the amplitudes of the corrections are not as pronounced as the real error values. Combining the corrections with SLAM results in a 20% reduction in heading errors. Here we have the same illustration but for displacement errors and suggested corrections. We observe a similar behavior regarding the real errors and the predicted corrections. By combining our correction prediction with the SLAM estimation, we achieve a 10% reduction in displacement estimation errors. In conclusion, our correction prediction approach is based on a supervised machine learning model. Therefore, an offline training phase is required. Once the training phase is complete, the predictions are carried out in real time. Our approach is independent of the sensor used. We validated our method on a real vehicle using a different sensor than the sensor used in the training and testing phases. The results we obtained are very promising, as we attenuate the heading errors by 20% and the displacement errors by 10%.